Good afternoon, students. Prishti sir is coming for the lecture 3 of the discontinuity of the electrostatic field. This topic deals with electrostatic pressure. Okay. So these are my credentials. All of you are aware, so that you can contact me in case of difficulty. Now we will discuss some cases of discontinuity. Lecture 1, lecture 2, they are over. Lecture 2, I discussed the discontinuity of the electrostatic field. Lecture 2, I calculated the how to calculate the field on the surface where there is discontinuity, and how to calculate the pressure also on the surface. Now I'll give some examples, very critical examples. It will clarify your basic concept very much. Okay. Example 1, very simple example. Calculate the electrostatic field on the axis of a circular area of radius r and having a uniform surface charge density sigma. A circular area. Area means zero thickness, mathematical surface. Also find the electric field at its center. All of you must have done this. Let us see the key points. This is circular area of radius r. This is the axis, dotted line is the axis, we call it the x-axis, and that is also the axis of the circular area passing through the center O. Consider a thin ring-shaped area with O at the center. As its radius is smaller and thickness is dr. Just see the diagram. Area of the thin ring, as you all of you know, the length into the thickness, that is 2 pi r into dr. Then how much will be charge? Sigma is the surface charge density. So multiply the charge area charge density with that elemental area. So sigma into 2 pi r dr. Electric field at point P on the axis of this ring will be how much? So all of you know, 1 by 4 pi epsilon 0 dq of the ring, okay, into x. X is the point on the axis from O, that point P. Distance from O to P is x. Charge, let me write charge dq on the thin ring so that I can write it. Okay, right? So dep will be, all of you know, along the axis, 1 by 4 pi epsilon 0 dq into x divided by radius of the ring square, r small r square, plus x square to the power 3 by 2 x cap direction. This is from the basics of the charge on the axis of a ring, charge ring, the field on the axis of a charge, uniformly charged ring. So this is the field direction. I can give a direction here. E. Okay. So this is dE at P is this. So take the constant terms at one place. X is the distance from O to P. Any ring you take, that P point will have same distance from O. So x will be treated as a constant here. Small r is the variable. This is the radius of the thin rings. So sigma x 2 pi 4 pi cancels. So 2 epsilon 0 denominator, sigma x by 2 epsilon 0 r dr by r square plus x square to the power 3 by 2 x cap. Remember, x is treated constant. So as I written here, x is constant for all such rings. No, it is not of, it is for. Okay, so integrating now this, we will get EP. So EP will get sigma x by 2 epsilon 0 outside. No problem, I take it, write it outside. And integration of this part, that is sigma x by 4 epsilon 0. You can simply integrate. Okay, take it 4, take 2 inside, make it 4. So 2r dr by r square plus x square divided by 3 by 2 will be minus 2 by r square plus x square root over 0 to r, 2 to again cancel, sigma x by 2 epsilon 0, and this is 1 by x minus 1 by r square plus x square root over, and direction is x cap. This is important. Then outside x, the inside also 1 by x, we can cancel out. No, no, no. That I can cancel only when x is not equal to 0. If it is 0, x is 0 means on the center x 0, I can cancel 0 by 0. That is mathematically unacceptable. So when x is not equal to 0, then I can cancel them. I can write EP is equal to sigma by 2 epsilon 0, 1 minus x by root over of x r square plus x square x cap direction. Only when x is not equal to 0. If x is equal to 0 at point O, center, we cannot treat x by x as 1, as 0 by 0 is not defined. So when x tends to 0 but not equal to 0, then also I can cancel x by x as 1. So E1 will be, E1 means, just refer to our previous discussions, 1 means just neighboring point of the surface, 2 also below neighboring point of the surface. So E1 will be just when x tends to 0, I can use this. I can cancel when x tends to 0. Then this term will approach 0 when x tends to 0. So sigma by 2 epsilon 0 x cap is E1 bar. And at x is equal to, it tends to 0 minus, that is the below lower limit at point number 2, E bar is equal to sigma by 2 epsilon 0 minus x cap, pointing down. So this is what I have written here also. n cap नहीं है, उसको हम ये कर देते हैं, x cap लिख देते हैं, ये x cap minus x cap, ठीक? Okay, that is same as n cap only. N is normal to the surface. So at the neighbor points of O or the center point O, on the both sides of the surface, electric field are having same magnitude but opposite direction, 180 degrees opposite to each other in direction. So electric field is discontinuous. Then is a vector. For the continuity, the that magnitude and direction both should be same at point 1 and point 2, but magnitude same but direction not same. So they are discontinuous. So as per lecture in lecture 2, what I told, both the fields are discontinuous. What is the field on the surface at the point of discontinuity? Arithmetic mean of the so limiting fields. That's it. Half of E1 bar plus E2 bar. That will be 0. This is same magnitude, opposite direction. Vector sum is null. Half null is null. So this is the, on the center, the field is null, means 0 magnitude. And the electrostatic pressure will be how much? As I told you, again refer to this lecture 2, half magnitude of E1 square minus E2 square. E1 square is sigma square by 4 epsilon 0 square. E2 square also sigma square by 2 epsilon 0 square, the magnitude square. Okay, and they will cancel out and pressure is 0. That means for the electrostatic pressure to be present, E1 and E2, the limiting fields on both sides, that magnitudes must be unequal. The magnitude is same, they are not going to be, there is not going to be electrostatic pressure as per this relationship. Okay, क्लियर हो गया ये? मैं ये क्यों बताया? क्योंकि आप ये जो x by x को हमेशा कैंसिल कर देते हो ना, before cancelling numerator and denominator, make sure that they are not 0. This is the major mistake we do in many of these situations. In many of these situations. Now let us go to the example 2. We calculated the pressure on the surface of a spherical surface. Where? In the lecture 2. I asked you in the last example, the spherical surface having uniform surface and sigma, what is the pressure on the surface? And the pressure was calculated to be P is equal to sigma square by 2 epsilon 0 using this expression for pressure. अगर वो स्फेरिकल सरफेस चार्ज डेंसिटी नहीं होके स्फेरिकल वॉल्यूम चार्ज डेंसिटी हुआ तो let us calculate the pressure at the surface of the spherical volume of radius r having uniform volume charge distribution in space having permittivity E naught. Volume charge density is rho. Surface charge density normal symbol is sigma. So this is the uniform volume charge distribution. थोड़ा उसको दिखा देते हैं भाई, यही है, ये स्फेरिकल वॉल्यूम है, रेडियस r है, ये rho is the volume charge density, so Q will be volume charge density into volume is 4 by 3 pi r, just common sense. Okay, and already you must be knowing the electric field of a uniformly charged spherical volume charge distribution is rho r by 3 epsilon 0 r cap, or if I want to write in terms of Q, then rho by epsilon 0, rho itself I can write as rho by 3, I can write as Q by 4 pi r cube. That's what I did. Okay, Q by 4 pi r cube, epsilon 0 is there. So this is the expression either in terms of total charge or in terms of charge density. Okay, this is when r is less than r. When r is greater than r, it just behaves like a point charge at the center of the sphere. So that is 1 by 4 pi epsilon 0 total charge by small r square r cap. R is greater than 0. R is the distance from the center of the sphere. Now, the same point 1 and 2. 1 is just outside, 2 is just inside. ये भी लगा देते हैं भाई. ये point number 1, limiting point just outside, limiting point just inside. So limit r tends to capital R, minus means from inside, that is E2. How much? E1. 1 by 4 pi epsilon 0, r tends to capital, so Q by capital R square, Q by 4 pi epsilon 0 capital R square r cap. Okay, similarly limit of E, r tends to capital R plus means from outside, that is E1, that is Q by 4 pi epsilon 0 r square, r is capital R square r cap. So compare the inner limit and outer limit, the inner neighborhood point and outer neighborhood point is same field, same magnitude field, same direction. Yes or no? So there is no discontinuity in the electric field at the surface. So it's clear. So therefore, electrostatic pressure, अरे मैं कभी कभी लिखना छोड़ देता हूँ, इलेक्ट्रोस्टैटिक प्रेशर. So the electrostatic pressure at the surface equal to P is equal to half epsilon naught magnitude of E1 square minus E2 square, which is also 0. Why? Because E1 and E2 same magnitude. So for a continuous charge distribution and a spherical volume, if the surface thickness is equal to T and surface thickness always tends to 0, the surface volume how much? 4 pi r square T. T may be tending to 0, but that is surface volume. Then surface charge how much? Rho times the surface volume is 4 pi r square T. Then what is surface area charge density? What is the areal charge density? That is surface charge density, that charge on the surface divided by area of the surface. So rho into T. So but T tends to 0. So obviously sigma tends to 0. So since surface charge density tends to 0, pressure on the surface tends to 0. As I told you earlier also, because pressure will be surface charge density into unit area on the surface. Charge density on the surface and unit area on the surface. This product will give you pressure. So if T itself, the surface charge density becomes 0, tends to zero, as small as possible. So pressure will be as negligible as possible. Clear? So on a uniform volume charge distribution on the surface, there is no discontinuity of the electric field and no pressure on the surface. Whereas on a only spherical surface charge distribution, as I told you in the lecture 2, there will be pressure because inside field is 0, outside field is sigma by epsilon 0. So there is a discontinuity. So you can calculate the pressure by P is equal to half epsilon naught E1 square minus E2 square. That magnitude of E1 square minus E2 square. Okay. Am I clear? Very good. So और एक वेरी इंपॉर्टेंट एग्जाम्पल के लिए हम एग्जाम्पल 3 के लिए नेक्स्ट पेज में जा रहे हैं. जाएंगे या फिर कोई डाउट है इसमें? डाउट है तो पूछो, नहीं तो नेक्स्ट पेज में बिल्कुल जाएंगे हम लोग. चलते हैं नेक्स्ट पेज में क्योंकि वो एग्जाम्पल बहुत इंपॉर्टेंट है. चलते हैं. चलो भाई नेक्स्ट पेज देखते हैं. नेक्स्ट पेज में क्या चीज मैंने संभाल के रखा. ओके ये हो गया पेज 2. हाँ पेज 2 में क्या सिचुएशन है देखते हैं. इसको लिखते हैं एग्जाम्पल 3. एग्जाम्पल 3. ओके ये क्या हेमी नॉन कंडक्टिंग हेमी स्फेरिकल सरफेस. तो डायग्राम थोड़ा सा गड़बड़ा गया तो फिर भी आपको समझ में आ रहा होगा. रेडियस कैपिटल having uniform surface charge density on the curved surface, that is sigma. Find out the electric field at the topmost point. बेटा ये पॉइंट जो है ना इधर ही फाइंड करो. ठीक. And also find the electrostatic pressure at the topmost point. So electrostatic field at the topmost point is just outside, just inside, on the surface. तीनों जगह फाइंड करो उसका जो इलेक्ट्रिक फील्ड, क्योंकि there is a chance of discontinuity because this is a single surface having charge distribution, charge density. So there must be a discontinuity in the electric field, as we have seen in our previous lectures, lecture 1 and lecture 2. Lecture 2, how to calculate the surface field, I have discussed. Solution देखते हैं. Solution में मैं क्या करता हूं देखो, I remove a vanishingly small area dA and shift it away. dA tending to 0. डायग्राम दिखा देता हूं. छोटा सा dA निकाल के इधर रख देता हूं. ठीक है. इसमें एक होल बन जाएगा. होल का साइज कितना? Negligibly small but not zero size. It's a finite but negligibly small size hole has been created, same size as the dA which I removed. Okay. E1 dash bar. E1 dash bar means electric field just outside dA with sigma by 2 epsilon 0 r cap just outside E1. E1. E2 just below point of dA. That is same E2 bar. E2 bar also will be sigma by 2 epsilon 0 r cap or call that whatever radial outward distance. Let me write also. Write करने से आपको ठीक ठाक रहेगा. ये sigma by 2 epsilon 0 r cap. नहीं तो आप हमेशा चू करते रहेंगे. ठीक है. जो डैश है that is for the dA and double dash will be given for the remaining part of the hemisphere. I'll come to that later. Okay. और सरफेस में क्या फील्ड रहेगा? ES dash, dash means due to the D area on its own surface, zero field. Already you have seen field at the center of the area will be zero, so that is zero field. ES, so ये तीनों ध्यान में रख लो, E1 dash, E2 dash, ES dash, दोनों all three vectors written. Let us calculate the electric field due to remaining part of the hemisphere, ये होल को छोड़ के बाकी सब का. एंड इसको हम कैसे डिनोट करेंगे? E1 डबल डैश बार, ES डबल डैश बार, E2 डबल डैश बार एट दी होल ड्यू टू द रिमेनिंग पार्ट ऑफ द हेमिस्फीयर. चलो ये डायग्राम देखते हैं. एक्स छोटा सा रिंग लेता हूं, एलिमेंटल रिंग ले लेता हूं बाबू, ठीक है. तो रिंग का ये अगर थीटा ऐसे मेजर कर रहा हूं थीटा, तो ये हो जाएगा, ये जो रेडियस ऑफ द रिंग होगा आर कॉस थीटा, कैपिटल आर कॉस थीटा, एंड ये विड्थ ऑफ द रिंग कितना, आर इंटू डी थीटा. सो एरिया ऑफ द एलिमेंटल रिंग कितना होगा, सरफेस एरिया ऑफ द एलिमेंटल रिंग, तो मैं शेडिंग किया, लेंथ इंटू विड्थ, दैट इज 2 पाई आर cos theta is the circumference length, and this is r d theta is the width. So 2 pi r square cos theta d theta. So the charge on the elemental ring कितना होगा, इसमें सिग्मा मल्टीप्लाई कर दो, चार्ज डेंसिटी, बस आ गया आपको. dq is this much. अगर dq आ गया तो ये p पॉइंट जो है on the top, what is the field due to the ring? Remember there is a hole here now. So whatever field will be produced, that will be continuous, because if in a space there is no charge, so field at that location where there is no charge, electric charge, will be a continuous field only. Okay, because there is no point for the field to terminate or originate, so it will be continuous field. So DEP कितना होगा, same just like a field of a ring on the axis, charge, the charge of the ring. This r minus x, if this distance is x, this is r minus x. R minus x is distance along the axis, that is the center to p distance. So that is k dq r minus x divided by radius square, that is r cos theta square, plus x square, r cos theta square plus r minus x whole square to the power 3 by 2, है ना. तो बेसिक फॉर्मूला फॉर द फील्ड ऑफ ए रिंग ऑन द एक्सिस. बट x इज r sin थीटा. देख लो ये x क्या है, r sin थीटा. x लगा दो इसमें, r माइनस एक्स विल बी r इंटू 1 माइनस साइन थीटा. dq की जगह लिखेंगे सिग्मा इंटू 2 पाई r स्क्वायर कॉस थीटा डी थीटा. नीचे क्या रहेगा, आर स्क्वायर कॉस स्क्वायर थीटा, आर माइनस एक्स इज आर 1 माइनस साइन थीटा स्क्वायर टू द पावर 3 by 2. यस और नो? तो दैट इज सिग्मा बाय, ये 2 पाई कैंसिल करेंगे, सिग्मा बाय एप्सिलॉन 0, ये आर क्यूब कॉस थीटा 1 माइनस साइन थीटा डी थीटा न्यूमरेटर में, डिनोमिनेटर में अगेन आर क्यूब, तो स्क्वायर को बाहर ले आओ, 2 3 by 2 मींस आर क्यूब, ये 2 माइनस cos square theta plus sin square theta होगा 1 plus 1 2 minus 2 sin theta, so 2 into 1 minus sin theta to the power 3 by 2. चलो ठीक है, हाँ ठीक है. r तो 0 नहीं है, मैं कैंसिल कर दूंगा, एंड ठीक है, ये 2 को भी बाहर ले आऊंगा, 2 into √2, so 4 √2 हो जाएगा बाहर में, तो सिग्मा बाई 4 √2 एप्सिलॉन नॉट, एंड इसमें क्या रहेगा, cos थीटा 1 माइनस साइन थीटा डी थीटा, डिनोमिनेटर रहेगा 1 माइनस साइन थीटा 3 by 2 टू द पावर 3 by 2 आर कैप डायरेक्शन. हाँ अगेन अभी क्रिटिकल पॉइंट आएगा, हम बोलेंगे भाई 1 माइनस साइन थीटा न्यूमरेटर डिनोमिनेटर से कैंसिल करेंगे. भाई तभी कैंसिल करेंगे जब 1 माइनस साइन थीटा इज नॉट इक्वल टू 0 और थीटा इज नॉट इक्वल टू पाई बाई 2. ऐसे तो एक छोटा सा एरिया निकाल देना, थीटा को हम पाई बाई 2 तक तो नहीं ले सकते हैं, जो भी जाएगा उसका बाउंड्री ऑफ द डीए तक वो पाई बाई 2 तो नहीं होगा, टेंडिंग टू पाई बाई 2 बट नॉट इक्वल टू पाई बाई 2. सो साइन थीटा में टेंड टू 1 बट नॉट इक्वल टू 1. सो इफ 1 माइनस साइन थीटा जीरो नहीं है, मतलब थीटा पाई बाई टू नहीं है, so we can cancel out numerator denominator, and because the dA we have removed, now we cannot integrate up to 90, we have to integrate something tending towards 90, yes or no? So we can cancel out 1 minus sin theta for numerator denominator. So क्या रहेगा भाई, क्या रहेगा ये, क्या रहेगा देखेंगे क्या में लिखा है रेड में. Now you can understand why he removed dA from tending to 0 from the top, due to which our limit of integration for theta ranges from 0 to theta tending to pi by 2, not equal to pi by 2. Equal to pi by 2 तो हम लोग फंस जाएंगे भाई. When theta tends to pi by 2, the point P is just below the dA area. When theta tending to pi by 2, then when equal to pi by 2, you come to the surface. But when just tending to pi by 2, just below the surface, this point P on the axis. Yes or no? वो बहुत important point है. So this point P just below the dA area when theta tends to pi by 2. That is the point 2. Integrating now from theta is equation 1 है, उसको हम इंटीग्रेट करते हैं 0 to theta tending to pi by 2 तक. देखो मैं इसे कैसे लिखा उसको, theta is equal 0 to theta tending to pi by 2 sigma by 4 root 2 epsilon naught. सो ये रहेगा cos थीटा, नीचे रहेगा 1 माइनस साइन थीटा रूट ओवर, क्योंकि 1 माइनस साइन थीटा पे कैंसिल कर दिया एक ऊपर नीचे से न्यूमरेटर डिनोमिनेटर से, बिकॉज 1 माइनस साइन थीटा नॉट इक्वल टू 0 व्हेन थीटा नॉट इक्वल टू पाई बाई. सो इसका इंटीग्रेशन होगा -2 इंटू 1 माइनस साइन थीटा रूट ओवर इटसेल्फ. सो थीटा इज इक्वल टू 0 टू थीटा पाई बाई 2. तो ये माइनस हटाएंगे, इंटरचेंज करेंगे लिमिट को, ये आएगा सिग्मा बाय 2 रूट 2 एप्सिलॉन नॉट. आ गया ये कौन सा फील्ड है भाई, E2 डबल डैश. डबल डैश मीन्स व्हाट, ड्यू टू द हेमिस्फीयर विदाउट टेकिंग द डीए इनटू कंसीडर. डीए को निकालने के बाद जो हेमिस्फीयर रहेगा, जो पोर्शन रहेगा, उसका कंट्रीब्यूशन डबल डैश है. सो E2 is E2 double dash is this much, but E2 single dash कितना है, due to DA only. ध्यान में रखना ये सिग्मा बाई 2 एप्सिलॉन 0 माइनस आर कैप डायरेक्शन. ये डबल डैश कितना, ड्यू टू रिमेनिंग पार्ट ऑफ द हेमिस्फीयर सिग्मा बाई 2 रूट 2 एप्सिलॉन 0 but plus r cap direction. But since there is no charge at the hole, so E2 double dash, ES double dash, E1 double dash, they are all continuous, field is continuous, they are same value, and that is sigma by 2 root 2 epsilon naught r cap. Okay, because there is a hole there. Now bring back the DA and place it at the hole. Then apply the principle of superposition. So what is E2 first देखेंगे, E2 dash plus E2 double dash. सिग्मा बाई 2 एप्सिलॉन 0 माइनस आर कैप प्लस सिग्मा बाई 2 रूट 2 एप्सिलॉन 0 आर कैप करने से क्या रहेगा, सिग्मा बाई 2 एप्सिलॉन 0 कॉमन ले लूंगा, 1 माइनस 1 बाई रूट 2 माइनस आर कैप डायरेक्शन. 1 क्या रहेगा, E1 क्या रहेगा, E1 डैश प्लस E2 डैश. पहले E1 डैश में जाएंगे. देखो भाई ये E1 डैश क्या है, सिग्मा बाई 2 एप्सिलॉन 0 आर कैप, and E1 double dash क्या है, sigma by 2 root 2 epsilon 0 again same r cap. So इधर आड़ हो गया बस ये 4. ES क्या रहेगा, ES dash plus ES double dash. ES dash how much, on the surface itself, due to the surface on itself the field is 0, ES dash is 0. अरे मैंने लिखा नहीं क्या, ES dash is 0. ठीक है, अरे मैंने क्या कर दिया, ये भी कहीं तो इधर भी लिखा होगा, मैं ES डैश, ये लिखा ना मैं, E1 डैश, E2 डैश, ES डैश, ये सब मैं लिखा ऑलरेडी. तो डायग्राम में लिख दिया अभी बस. तो ES डैश एंड ES डबल डैश. ES डबल डैश क्या है, यही है अभी लिखा मैंने, सिग्मा बाई 2 रूट 2 एप्सिलॉन 0 r cap, because E2 double dash, ES double dash, E1 double dash will be same because it's through a gap, this is through a hole, and there is no charge on the hole, so field is continuous. So E2 double dash कितना हुआ, sigma by 2 epsilon 0, sorry, ये तो इंट्रोड्यूस हमें कर दिया. ES कितना होगा, ES single dash, ES dash is 0, ES double dash is sigma by 2 root 2 epsilon naught r cap. So that is sigma by 2 root 2 epsilon naught r cap. You can cross check that. The arithmetic mean of 4 and 6, that is E1 and E2, will give you the ES also. Okay? Am I clear? So electrostatic pressure at point P क्या होगा, half epsilon naught E1 square minus E2 square का जो मैग्नीट्यूड है ये कर दो, half epsilon naught sigma by 2 epsilon whole square 1 plus 1 by root 2 whole square minus 1 by root 2 whole square. ये just E1 square minus E2 square. E1 मालूम है आपको, ये E2 भी मालूम है, इसका मैग्नीट्यूड का स्क्वायर ले लो, सबट्रैक्ट कर लो. ओके, कितना होगा, हाफ एप्सिलॉन नॉट सिग्मा स्क्वायर बाय 4 एप्सिलॉन स्क्वायर, ये होगा ए प्लस होल स्क्वायर माइनस ए माइनस, सो 4 into AB, 4 2 root 2. So 2 cancel, so 1 sigma will be epsilon cancel, so 1 will be how much, 4 root 2 by 4, so that will be 2 root 2 denominator. So this is the pressure, electrostatic pressure कितना है, sigma square by 2 root 2 epsilon naught. If you want to calculate pressure, as I told you also in this discussion, surface field on the surface into sigma, that the pressure field on the surface, already how much we found out, sigma by 2 root 2 epsilon naught into sigma square by 2 root 2 epsilon naught, one line में same. Are you observing this? So this is a very important point. Some people have raised this and many people have discussed in a very various manner. I don't want to go into detail what others discussion, but we are consistent in our discussion. We are consistent in our approach. We have consistently proceeded from lecture 1 to lecture 3 in applying this discontinuity of the electric field at the mathematical surfaces having finite non-zero surface charge density, okay, and also the electrostatic pressure because of that. And we have dealt with many examples, and various other examples will be there. If you have any problem in any of the any difficulty, any problem, you can always contact me. I am going to give in future certain extremely important application of this continuous charge distribution field and the pressure, etc. Force on two halves of two uniformly charged solid hemispheres. So like this, we will ask a various questions which you might not have done in your books. Okay, leave it the electrostatics to Prustisar. Any question in our limited to our syllabus, will definitely be able to answer, at least try to answer. We'll try to answer, because this is in a cooperative manner we answer. You ask a question, I'll try to answer. May take some time to answer, but definitely answer. Otherwise, I'll say it's not answerable. Yes or no? Okay. I think very soon I'm going to discuss, change the topic a bit, then come back to electrostatics again. Okay, all of you clear? I'm going to page 1 to write that it is a page. Otherwise, आप चूचू करने आ जाएंगे भाई page 1 कि आप लिखे नहीं page 1, वो सब मैं सुनना नहीं चाहता हूँ. ये है page 1. ठीक, लिखेंगे कहाँ? देखेंगे यहीं कहीं लिख देंगे page 1. चलो, अभी आपको सब कुछ समझ में आ गई? कोई दिक्कत है, कोई डिफिकल्टी है? नहीं है? चलो, आप लोग try to come to my video lectures regularly. Try to understand whatever difficulty you are having. You can raise, subscribe if you have not yet. so that you'll get a notification when I'm uploading next conceptual video. Okay, all the best to you. Have a good day. Bye for now.